Now we'll discuss about the plotting of the planes and linear bodies on stereonet. This is the topic. So how the planes are being plotted, how the linear bodies are being plotted in stereonet. The planes with the deep amount are plotted on the grid circles. Their poles are plotted as points by counting 90 degrees from the 2D point, and the lines are plotted as points. The plunge of the lines and the rays can be plotted. So how it will be possible? Let us see the example. We have to find out this plotting. Altitude of a bed is north 80 degree west, 40 degree south. So how can we plot it in stereonet? So this is the stereonet, let us say, over which we place the overlay, and we mark these points north, south, east, west, and we first draw this primitive circle which will use to show the strike lines. So here strike is north 80 degree west, so this point will be north 80 west, so the opposite point will be south 80 degree east. So these 2 points will have to be marked on the primitive. Then we bring this point to north and south line, and we know that its deep amount is 40 degree towards south, so to this side, if this will be the strike, deep will be towards this side. So when we rotated it to this position, and we have to count this amount of deep in the great circle in north-south position from this side, So we will get a circle like this. This will indicate 40 degree. So this great circle will indicate the plane which is having 40 degree dip towards south, and strike is north 80 degree west, south 80 degree east, and its pole will be along this line. On this line we have to count 90 from this point. So this amount is 40, this is 50, then we have to count another 40. So this point will be the pole of this plane. So we now have plotted the plane and its pole. So here it has been described. Place the overlay on the stereonet, draw the primitive circle, mark north, south, east, west lines, and north 80 degree, south 80 degree, east and the periphery. These points. Rotate the overlay, place north 80 degree, west, south 80 degree in the north-south line on the net. Deep will have to be measured along east west, this line of the net. As dip is towards south of the strike, its dip will have to be measured from the west. So this is the, from this side it has been measured, and this the line, the great circle is being drawn, which this ABC circle, great circle is the plane. Its pole will be at D, found out by counting 90 degrees from C. So this will be the D pole. So this is the way how we plot a plane and its pole. Next we will switch over to the next problem. Let us say a plunging fold hinge has a orientation 30 degree south, 42 degree west. Plot it on stereo net. So this is a linear feature. Hinge is a linear feature. So it can be plotted with respect to its plunge, and it will appear as a point. So plunge is 38 degree, and this is the direction, because we have already discussed how we plot the lines. Lines are represented by the plunge amount first, and then the direction of plunge. So this is the direction of plunge, this is the plunging amount. So in stereo net we have to put the overlay, mark these points east, west, north, south. North, south, this is east, this is west. So the direction is south, 42 degree west. So this is south, 10, 20, 30, 40. This is south 40 degree west line point on the primitive circle. So this is the center. Along this direction, the plunge amount is 30 degree. So how can you get this point? We have to rotate this point to the south point and read 30 degree from these circles. So the point where these small circles representing 38 degree touches this line will be the point, will be the point indicating the plunge. So let us see how it has been drawn. It has been shown here. The overlay is placed. This is the overlay. Underlay the stereo net. North, south, east, west lines marked. Point A is indicating the south 42 degree west direction. The OA line joined, overlay is rotated to bring it to north-south line. Plunge amount 38 degree is read inward through the small circles along north-south line from south as point B. So B is the point representing the plunge of the hinge line. Alternatively, OA line may be rotated to east-west of the net. 30 degree can be read from the western end through big circles as point B. in both the cases the point B will be the same. So this is the way how we plot the linear features. So linear features, in case of linear features, we plot the direction and the plunge amount. Next, we will go to find out another problem, that is a cleavage is oriented 110 degree 43 degree southwest. It contains a mineral lineation tending 160 degree. Plot the lineation and determine its plunge. So here we have been given a cleavage plane with its strike and dip direction, and this plane is containing a linear feature tending 160 degree. We can plot this lineation and we can determine its plunge. So how we can go for it? Let us see. So first we have to place the overlay under the underlay. This is the overlay. The 110 degree, this is the strike. So this point will be 110 degree. If we calculate from 0, this will be 90, this is 110. So this is the strike line, and it is 43 degree southwest, because if this is the 110, according to right hand rule, the dip will be towards this side, so that is southwest. So we bring this line to north south direction, and as the dip is towards this side, so from this side we started counting 43 degree dip and draw the great circle representing 43 degree dip. So this is the plane which is having 43 degree dip, and this plane contains the lineation which is tending 160 degree. So 160 degree means it is the direction. So we will bring the net, we will bring the overlay to its original position, indicating north point, south point, and then count 160 degree from the periphery to locate the 160 degree point on the, this is 160 degree point on the periphery or on the primitive circle, and in order to find out the plunge of this line, plunge. So this will be the plunge, this will be the plunge. So how can you measure this? So you have to bring this either to south line or to the west point. If we bring it to south point, we read the small circles. If we bring it to the western point, we read the great circles to identify the value of this point. So this has been done here. So this is the 160 degree direction, and here this 60 degree direction touches the plane, because on the plane the lineation is contained. So somewhere here, as this is the plane is containing the lineation, so this is the point of lineation oriented along north 160 degree direction. So we have to see how much is this this will give you the plunge. So rotate to bring 160 degree line to north-south diameter. Read up to the point C from south through small circles. Plunge is 34 degree. If we will bring it to western side, then from this side we can also measure in terms of the great circles. So plunge is 34 degree in case of this lineation oriented along OC direction having orientation value 160 degree. So we could know how a plane is being plotted and a plane containing a lineation, how it can be shown in the stereo net. We will switch up to next problem. Cleavage in an area shows orientation 110 degree, 43 degree south. It contains lineation with 34 degree plunge along 160 degree direction. What is the rake of this lineation? It is just same problem. Here it has been asked to find out the rake. In same way, we can proceed. And this is the direction, and this is the position of the lineation, and we want to calculate the rake. Rake is calculated in the same plane. So this is the plane. This is the plane. Plane containing this lineation. Lineation is represented by this point. If you calculate this one, this will give you the plunge. If you calculate this amount along this, through the small circles, that will give you the rake. If we measure this amount, this will give you the plunge. If you measure this one, D to B along the plane, that will give the rake. So how it has been shown, let us see. Draw OA, dip and dipping plane. Dipping plane has been here. The dipping plane has been drawn. Find out the intersection of the OB to the plane of the cleavage at B, touching the primitive at C. So this is the plunging direction. BC measured along north-south line is 34 degree. But BD part of the great circle shows the passing of the small circle at B, showing reading 58 degree, which is rake. So when we this will give you the plunge or dip. And along this line, if you move on the plane, we will get the rake. Rake of a line is the angle that this line makes with the strike, and it is measured on the plane itself. So this is the plane. This is strike end, and the point is here. So we have to measure along this line, along this great circle up to this point. So how? We have to see which great circle passes through this point. That is 58 degree circle. So the rake is 58 degree. So this is the way how we find out the rake, find out the plunge of linear bodies, and we have already discussed how the planes are being plotted in the stereo net. Next question, let us see. A cleavage is oriented 110 degree 43 degree south. A mineral lineation on the said cleavage plane has a rake of 50 degree east. What is the bearing and plunge of the lineation? Same question put in a different way. Cleavage has been given with deep and strike. So first we have to draw the cleavage. So this is the cleavage having 110 degree strike, deep amount 43 degree, this is 43 degree. The mineral lineation on the shared cleavage plane has a rake of 58 degree east. So we have to see read of 58 degree from east end along the great circle. So the use of small circles passing through 58 degree point. So this is the deck is 58 degree east. So we have to bring the small circles which is having value 58 degree. So this is the small circle with 58 degree value. So the point of intersection of this circle with the great circle is the point B. Now we will draw the line from O to B extended to reach the periphery at D. So D point as read from the primitive will give the plunging direction and this amount will be the plunge. So rotate OB line to NS line, north-south line with B at the south end, read of DB along north-south to find the plunge. DB and the direction can be read directly from the primitive. So this is the way how we solve this problem through stereo net. Same question, it is put in different ways. Now let us see another question. At an outcrop, bedding orientation is south 80 degree west, 20 degree south, and cleavage orientation is north 30 degrees, 70 degree east. Determine the orientation of the cleavage, bedding, intersection, lineation. So here we see there are two planes. When two planes join together, they produce a line. And this line is having its direction and is having its plunge. That we have to detect through this problem. So how we can go for it? The usual process of presenting these two planes are two circles, two great circles, or two great circles are drawn, met at the point A. This is the point A, where two great circles meet. So the line OA touching B at periphery will give the point B. In the primitive circle will give the direction of the lineation. Then to find out its plunge, we have to measure this along either north-south line or in east-west line. So draw OA line, extend it to touch the primitive at B, bring OB line to north-south line of the net, read of AB throw small circles to find out the plunge. OB direction is the red from the primitive to indicate the trend of the lineation. So this is the way how we solve some of the problems related to dip and strike through use of the stereo net. This is all about my discussion that is related to your deep strike, how deep strike are being plotted, how planes are being plotted, how linear features are being plotted, how we go for plotting a plunge, pitch or rake, and how we plot the poles of the planes. All these things we have discussed in a simplified way. I think, my dear students, you will not face any problem. All right, thank you.